All right, so, am I frozen? What's going on? Okay, here we go. Okay, guys, let's talk about, there's a lot of different ways to do this, but let's see, any ideas of how we could simplify this? Our goal, remember our goal is to get here. We're going to pretend like that's not there, though. Yes. Okay, so sine of x over cosine of x. Okay, everybody watch. This is noticeably different than many of you did it. She is absolutely valid. I love it. It's beautiful. Then we have over cosine of x. So then what's your thought process? You're awesome. Beautiful. I love that way. That is different than a lot of people did it. Equally as good. Yes. So anyone else have a different way? Quicker. Way. You. Tell me your way. Yep, so he said tangent's 1 over cotangent, so then times cotangent over cosine of x. So then do you see how that was equally as good? So we would get 1 over cosine of x equals secant of x. So that would be the work that would be expected to get full points on the test. Awesome. There's other ways to think through it as well. As long as your stuff checks out, your algebra checks out, you're good to go. Okay, let's begin 6-4. So you're going to be needing possibly to take some notes, but honestly, guys, we know what we're doing. We've done unit circle. We've done right triangle trig. This is no different. It's now, honestly, this lesson is going to be so easy for you. So just a new vocabulary, basically. So it says, let theta be an angle that's in standard position with an xy point on the terminal side of theta. So everybody remember, standard position means we're creating an angle on an xy chart here. Here is my initial side. I open to a terminal side here. There's my xy point. It says our r is going to be equal to the square root of x squared plus y squared, and then r cannot equal 0. So I'm going to remind you where this is coming from. Isn't it true that a circle's equation is x squared plus y squared equals radius squared? So now to figure out the length of the radius, couldn't I just square root both sides? So r is equal to the square root of x squared plus y squared. Now can anyone tell me why can r not be 0? Why would that not make sense? Good point. A circle wouldn't be a circle if it doesn't have some length of a radius. It would be just like a point, right? 0, 0 here or whatever. So good point. A radius has to have a length. Now these are the trig ratios that happen. We already know these. You don't even need to write them down. It's just showing you we can take any xy point right here or right here or right here. And can't we create a right triangle right here with that? And now what do we know? Sine is y over r. This is our radius. So that's the same thing as saying opposite over hypotenuse. Does everybody see? So then cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Do you see where they're getting these from? All right, and then we know that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now just to remember, S and C are the reciprocals, the opposite, you know, because that kind of helps me do it quicker. Okay, awesome. So now let's look here. This is just a new word for us, reference angle. So it says, let red angle theta be in standard position. Its reference angle will be the acute orange angle theta formed by the terminal side and the horizontal axis. So basically we already know how this works, like, right? This is the point of the unit circle. Now we can extend our knowledge of trig to obtuse angles, correct? Negative angles and so on. So everybody, a reference angle will be the acute angle inside the right triangle here. Everybody good with what a reference angle is? The one that creates the right triangle. So let's begin. So looking at this, one thing I want you to know, for your ACT, you're not going to want to draw out the entire unit circle. That takes too much time. You're going to want to only draw out quadrant 1 and then extend your knowledge to the entire unit circle. Because think about it. Do you see how right here is a 30-degree triangle? Wouldn't this also be my 30-degree triangle using that reference angle right there? Does everybody see? So if you know, if they ask you to do trig of 150 degrees, in your head you only have quadrant 1 drawn out, for example, on your ACT, and you'd say, okay, well 150 is up 30 degrees from 180. So you'd say, I'm just going to look at the 30-degree angles xy points, And then I'm going to just know that since it's in quadrant 2, it's negative x, positive y. Negative x, positive y. Does that make sense, everybody? Because you only want to have quadrant 1 drawn out for the ACT. Are you good with that? Okay, cool. So same thing with 45 degrees. We're going to have all of these triangles, but we'll only have quadrant 1 drawn, and then extend our knowledge to every quadrant. Same with 60 and so on. Okay, here we go. So let's see if you can do this one without my help. It says, let negative 3 comma 4 be a point on the terminal side of theta. Find sine theta, cosine theta, tangent theta, cosecant, secant, cotangent. Ready, set, go. You guys there? Okay, so pretty easy stuff. You know, you went negative 3 units up 4 units. You did Pythagorean theorem and got what as the hypotenuse? 5? Perfect. And then we would put our theta here, and then sine is, oh heck, right? Opposite over hypotenuse. Sine of theta is opposite over hypotenuse, 4/5. Cosine of theta is negative 3/5. And then tangent of theta is opposite over adjacent, 4 over negative 3. So now we know the reciprocals, right? Cosecant, secant, cotangent, and that is super easy. We would just flip them. Okay, cool. Let's look at another one. It says, given the tangent of theta, yes. Yeah, because that was negative 3, so that's why we're drawing it in quadrant 2. Okay, so it says, given tangent of theta is negative 5 over 4, and cosine of theta is greater than 0, find sine and secant. So what this is, guys, is this is giving you hints on where to draw this in, what quadrant. So let's think about this. Isn't tangent y over x? Sine over cosine, correct? So now you say, okay, well, now next thing we know is that the cosine of theta is greater than 0. So doesn't that mean cosine's positive? Isn't cosine our x values? So our x values are positive. So we know we're over here somewhere. But then doesn't it make sense that since the one of them's negative, then we can't, well, I mean, we have to go down somewhere, correct? So we're down here. So now I'm able to draw my right triangle. So then this would be my y value, negative 5. My x value must be 4. My hypotenuse would be square root of 41. Pythagorean theorem to get that. I did that all day today, so that's why I have it memorized. But I know you know how to do the Pythagorean theorem, so I'm just trying to not waste your time. So you'd say sine of theta is opposite over hypotenuse, which would be negative 5 over root 41. What would that rationalize to be? Perfect. 5 and 41 don't simplify, so you're done. And then you say secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So then you'd reciprocate that hypotenuse over adjacent. Pretty easy stuff. Okay, cool. Tell me the answer in 30 seconds, not even. What's the reference angle here? Positive 60, right? Because we would draw in a right triangle, boom, that would be 60 degrees. There's our reference angle. It's the acute angle that allows us to draw the right triangle. Sweet. Okay, so now let's look at this. It says, find the reference angle. That means find the angle that allows me to create a right triangle, the acute angle. I don't like to draw negative angles personally, so I'm going to find the coterminal angle, draw that in, and then find the reference angle of that because it would be the same reference angle. So I'm going to add 360. Can anyone tell me what that is? 225 degrees. So let's look at where that is. If I start here, go around 180 down to 225. So then the reference angle would be this angle right here. Is everybody with me? So now let's just do some algebra. There's so many ways to do this. I would go, okay, to find that angle, I would do 225 minus 180 because that would give me the leftovers. So what would that be? 45 degrees. Okay, now why is this useful? So we've answered the question, but here's why this is useful. This is useful because if I said to you, find the sine of negative 135 degrees, if you use this information, you have on your ACT this 45 degree angle of root 2 over 2, root 2 over 2. You would say, okay, I'm looking at the 45 degree angle. It's just, this is ending in quadrant 3, correct? So you'd say, okay, so these are both negative. And now you could just do the trig really easily, but you only have to have quadrant 1 drawn in. Okay, what's the reference angle of 2.3? Now notice this is radians, not degrees. Also notice there isn't pi. Well, pi is there, it's just pi has already been multiplied into that. So remember, radians is just physical distance of the outside here. So these are pi radians. Let's put their decimals as well. So 2 pi would be about, 2 times pi in your calculator would be about 6.2 radians. Okay, now pi over 2 is about how many radians, decimal radians? What is it? 1.6 radians, decimal radians. This is about 3.14 decimal radians. And then if you type that into your calculator, I believe you get about 4.5 decimal radians. So now let's think about drawing this in. It's at 2.3 radians. Here's my initial side. Wouldn't 2.3 be somewhere over here? Because this was 3.14, so I'm going to go 2.3. So that was to there. So now our reference angle is this angle here. So how could we find that? $3.14 minus 2.3. So that would leave me with that distance from there to there of 0.84 radians is our reference angle. Is anyone confused? Pretty easy? Cool. Okay, use reference angles to find 4 pi thirds. Once again, you were trying to figure out how to use kind of like just quadrant 1 here. So, because you're not going to have the full unit circle drawn here. So first of all, reference angle, that would be the acute angle. So, there's so many ways to think about it. What do you guys suggest here? Which quadrant is it in? Like that will help us. Okay, now think about this, guys. Does this help? Isn't this 3 pi thirds, everybody? Yeah. So wouldn't going 1 more pi thirds be like in here somewhere? So it's in quadrant 3. Was everybody able to see how I was able to figure that out? Now remember, 1 pi third is actually, this is pi 6. 1 pi third was up here, right? It was the 60-degree angle. Okay, so now let's look at that. We know our xy point at 60 degrees since we're only using quadrant 1. What's my xy point? Root 3 over 2, 1/2, or 1/2 root 3 over 2? 1/2 root 3 over 2. And then you'd say, but we're talking quadrant 3, therefore negative x, negative y. Is everybody with me? So now you'd say the cosine is x, which is negative 1/2. And we were able to answer it based on quadrant 1. Yes. The third. Pi third? Yeah. This is 1 pi thirds right here? Because this distance right here, if you did 180 minus, well, let's see. How can I explain this better? This angle right here is 60 degrees as well, so we could just use this 60 degrees and then change our xy points. So how do we know it was 60 degrees? Well, because the pi thirds were the 60 degrees. So this is 1 pi thirds, this is 2 pi thirds. You see how I got 3 pi thirds. So then 4 pi thirds actually would have been more drawn better, more down here. Does that make sense? I'm not drawing it very good to scale on accident. Does that make sense, everybody? Yeah. That looks more like 30, doesn't it? Yeah. So maybe, is that what's throwing you off? Okay, so this is more drawn down here, right? Sorry about that. So that's a lot better of a drawing there. Yeah. Yeah, I can see why the confusion. I didn't draw that good at all. So now I'm able to say, well, those are the same xy points, but now they're just negative. Okay, cool. Good question. Okay, another one. It says, use the reference angle to find tangent of negative 210. Once again, I personally like positive angles, so I'm going to add 360. So we're talking the tangent of 150. Now, once again, you have not drawn a unit circle for the entire thing on your ACT. You only have quadrant 1. So you would say to yourself, this is exactly what you do on the ACT. 150 is in quadrant 2. Now, 150 is the same as either 30, 60, or 45. Which one? 30. Does everybody see why? 180 minus 150. The reference angle is 30 degrees. So you'd say, okay, we're looking at those XY points of 30 degrees. So isn't that, yep, root 3 over 2, 1/2. And then because it's in quadrant 2, that would be negative x. So now we'd say, okay, tangent is sine over cosine. So we'd do 1/2 divided by negative root 3 over 2. Dividing fractions is easy as pie. Flip a second and multiply. So our final answer would be negative root 3 over 3. And that would be worth, that took us about a minute on the ACT. It was worth the minute because we got it right. Okay, awesome. Doing okay? Yeah. Going too fast? Making sense of the reference angle. Okay, cool. So what about 11 pi force? Reference angle here. So let's think about this. It's pretty straightforward, isn't it, a pi force? But there's 11 of them, correct? So let's think about where that ends. Which quadrant is the question? You could subtract 2 pi. That'll make it easier. It is. So everybody, for those that can't just see this in a second, type in your calculator. 11 force minus 2, math, enter. What do you get? 3 pi fourths. So everybody, here's 1 pi fourth right there in the middle, correct? 1 pi fourth. And then that same distance would be 2 pi fourths. So then 3 pi fourths is right there. So you'd say, okay, we're talking quadrant 2. You only have quadrant 1 drawn in. Our XY points are roots 2 over 2. 45 degrees is our reference angle. Does everybody see? So negative x, positive y. So then you'd say, okay, cosecant's the reciprocal of sine. Sine of theta is negative root 2 over 2. So cosecant would be negative 2 over root 2, which would rationalize to be negative 2 root 2's over 2, which would be, is it positive? Yeah. Negative x, positive y, because I used x, didn't I? But I should be using y. Good catch. So now we can just quickly change our answer, luckily, because the algebra would be the same, but positive. Good catch. Thank you so much. Do you see that I used cosine? Yeah. Okay, cool. All right, good catch. Is it making sense? Going too fast? See, we're almost, oh, that was the end of the lesson. So, yes, sweet. Ready, go, work on the homework.